Hey everybody. Today we're going to talk about Cramer's rule. This is chapter 11, section 8. And believe it or not, we have reached the end. This is the last of our little chats here together. I know that makes you sad, but it's going to be all right. You can come back and take more math anytime you want. So let's get started here. First of all, I wanted to remind you that we have several ways that we've already learned to solve systems of equations. We know how to do it with substitution and the elimination method. Those are both really good ways to do, good standbys, but they work best with small sets of equations. Two equations, maybe three. Um, and if you have six variables, then you're going to have six equations to solve that, at least six, right? And so substitution and elimination work nicely, but when you get bigger sets of problems, you need bigger tools. And one of those that we have already seen is the matrix thing. And matrices are probably your best friend when it comes to big sets of problems. Now, the Gaussian elimination is a way to do that by hand. We just did that. Row operations is kind of another name for that. Um, Inverse matrices is another way. We did not do that. We're not going to do that. It's in chapter 11.7 if you want to see it, but you're not responsible for it and stuff. Today, with modern technology, all that, that has come around since I was in school, frankly, 30 years ago. Um, it's easy enough to put in a set of equations into your calculator and do the RREF on it. But I did want to show you one more way here. This is called Cramer's rule. And Cramer's rule is a really nice trick, especially back in the day before calculators would just spit an answer out at you. So that's what we want to look at today. Um, Before we can do that, I got to tell you about determinants. Every square matrix has a number that's called the determinant. Um, this number tells how well it will scale, what kind of roots you're going to expect out of everything. It's an interesting number. Maybe it's the fingerprint of the matrix. It's the number that describes how it works and stuff, whatever. But make no mistake here, it only works with square matrices. And so that's an important word in this little definition right there. Here we have a square matrix. A, B, C, D, two rows, two columns, and we want to take the determinant of A. You can see they've put these bars right here that are a little bit reminiscent of the absolute value. And this is kind of like the absolute value because we are measuring that matrix. Remember how the absolute value of, say, -7 said, the length of it is 7. It gave just a number that described what was going on. Didn't tell us the direction or anything. When we come in here with these bars, it's a little bit like we're measuring that matrix and getting a number that tells us how it belongs, what's going on with it. It's really easy to do. With a square matrix, it's 2 by 2. All you got to do is take this number, multiply it by that number, so that's your AD, and then you subtract what happens when you go the other way, minus BC. Okay? You do have to put the negative sign in there, so don't miss out on that one. But that's all you got to do for a 2 by 2. We'll do one 3 by 3, and you could see how to keep going with it if you needed to do a bigger one. Um, but that is the determinant, how to get this number that describes the matrix. Here's a couple examples. So to take the determinant of A properly, you should put these bars and say, I'm going to take the determinant. And then you wouldn't have the little hook bars anymore. You would just have absolute value bars, if you will, just straight bars like that. But all you got to do is take the -2 times the 1 and then subtract 0 times 3. And of course, here I would have -2 minus 0 would be -2. That's the determinant. Okay. That's this number that we need in order to do Cramer's rule. Over here, I would go 8 times 4, which would be 32, and I would subtract 5 minus 1, and that's going to be 27. I look at the third example here, And I go, uh-oh, this one's got one, two, three rows, but only two columns. That is not a square matrix. I cannot take the determinant of a matrix that's not a square. So I would just leave that one alone right there. Doesn't even make sense to talk about. Now, here's a 3 by 3 matrix, and that's square. 3 rows, 3 columns. So we're good to go right here. Only we've got to do something a little bit different. So let me show you how to work your way through this. And the thing that you should know here about this is that it's a little bit like distribution. What we're going to do is take this number right here, the first one, and then eventually we're going to take the second one and the third one. We're going to work our way all the way across there. And because we know so well how to do a 2 by 2 matrix, determinant rather, the thing that we're going to do here is cross out the row and column that's on. So once I've picked that first digit there, first element, I can come in here and block out this row and this column. And this is what's left, that little piece right there. That little piece is called the minor of a matrix. And um, so what I'm going to do is take that 2 to expand this thing out to get it down to where I know what to do with it. I'm going to take the 2, and then this right here is going to be, I still have to take the determinant of that. So just write that down, 4, 7, 1, -2. Okay. Once I've done that, I'm going to move on over to the next number, and I'm going to do it again. Let me show you what that's going to look like. I'm going to erase all this stuff here. And um, then now this, I should have taken out the box too. This is our um, number that we're working on. That's where we've gotten up to here. And I'm going to take out this box. Should have done that before. And we'll get our shady thing back. And we want to knock out the row and the column that element sits in. Okay. And I look and there's a 2 and a 7 and a 3 and a -2. That's what I need to put in the, yikes. That's what I need to put in the box there. So that's going to come over here. Gotta get my red back. And there's a 2, 7, 3, -2. 2, 7, 3, -2. Okay. So that's the second part of this thing. And then the third part would be to move on over to the last place. So let me get my eraser out again. And we will take out all of that. And these little marks don't apply anymore. And I want to come in here and focus on this number. Did the 2, did the 1, did the 0. We're going to work our way all the way across that top row. And let's shade out the row and the column that one's on. So we're left with this 2, 4, 3, 1. And that is the minor that we need. I've got the 0 from the top row, and then I need this little minor, the little piece of a matrix right there. Okay. So we just broke that 3 by 3 matrix down into 3 2 by 2 matrices. And again, it's a little bit like distribution if you want to think about it that way. The last thing that I have to do here is change signs on each one of these. So it's going to start off positive. Second one is negative. Third one is positive. Okay. You just go through and say plus, minus, plus. All right. And now we know how to do this thing because we've got our little rule that says in a 2 by 2, you just take this minus that. All right. So I'm going to write all that out. I'd have that 2 out front. Let's put some brackets to hold that 2 outside until we're ready for it. And then in here, I've got a 4 times -2, which would be -8. And then I'm subtracting 1 times 7, which would be 7. And I move on to the next one. I've got -1. Here's some brackets for the determinant of the second minor. 2 times negative 2 would be negative 4 minus 3 times 21. I'm sorry, 3 times 7 would be negative 21. Negative because I'm subtracting it. And then the last one here, you've got that 0, so we know it doesn't really matter. We're multiplying by 0 here. But 2 times 1 would be 2. 3 times 4 is 12. I've got to subtract that. There's everything that I need. And you can take as much time as you want to cooking this thing down. I'm going to get a negative 15 here, and here's a minus 1 times negative 25. And of course, anything times 0 is 0, so all that goes away. And almost finally, 2 times negative 15 would be negative 30. Negative times a negative is a positive 25. And right here, I'm going to get negative 5. Negative 5 is the determinant of that matrix up there that we called A. And to me, that's the easiest way to get that determinant, at least, for a 3 by 3. And that. Anyway, there is another way down here at the bottom. What you have to do is you have to take the 3 rows of the actual matrix, square matrix, and then take A1 and kind of copy it over. Take that first column and copy it over, and take the second column and copy that one. Okay, so you've kind of expanded that matrix there. It's only a trick to remember how to to multiply this thing out. If you want to do that, then you take the A1 times the B2 times the C3. You're just working that diagonal down like that. And there's the first term. And then you take B1 times C2 times A3, multiplying all three of those numbers and add that. Remember when we did the 2 by 2? We took everything that was going down at an angle positive, everything that was back up as a negative. You see how they're doing that here too. When I do the C1 times the A2 times the B3, then uh, that's right there. But when I come back up with the blue, now all three of these are subtracted here. If I wanted to, let's just get started. I don't know that we need to do the whole stinking thing here. But if I wanted to do this with the one up here, I would need to take that first column and put it, and the second column would be 141. And that's all I really have to do. So here in red, I'm going to take 2 times 4 times negative 2. And then I'd move over to the second row and I'd have 1 and 7 and 3. And because I'm going down here, we're adding that one. And then I'm going to take the 0 times the 2 times the 1. Everything got clobbered up here. I'm sorry about that. Uh, but you get the idea, right? If you like that, go for it. Okay, that works fine. When you come back up with the blue arrows, the other way, you got to remember to subtract those. So I'd start here and I'd have 3 times 4 times 0. That's going to be a 0, obviously, but I'm going to write it in anyway. And then I would subtract the next one, 1 times 7 times 2. Anyway, this should give you the same answer. We got one more to do here, which would be, where is it? Right there. Negative 2 times 2 times 1. All right. And so that would take care of all of that. Okay. Multiply that out if you want, play with it, make up some of your own. There's plenty in the book. I suspect that my open math is going to have some. But when you get done with all that, you're going to have a single number, and hopefully it's negative 5. And that would be another way to take the determinant of that matrix. Now, you could also do this one other way. And just let me mention this here because, again, we have a calculator. I could come over here and edit a matrix, and I'm going to set up a 3 by 3, the numbers that we had right there. So that would be 3, enter, 3, enter. See if I can still read those numbers after making such a mess up there. 2, 1, 0 moves down to the second row, 2, 4, 7, and 3, 1, negative 2. All right. So now I have my matrix entered into the calculator. I can quit. I can call up the matrix functionality again, step over here to the math menu, and you can see the first one is DET, which is short for determinant. So I want to take the determinant. I got to remember which matrix I put that in, but I think there's only one. So matrix A, yeah, there's my 3 by 3 matrix. And I say, go get me the determinant of matrix A, and there's the -5 that way. Okay. So, at some point, if you had big matrices and you got this, then probably makes sense to do that. Although, if you were going to do that, why not just do an RREF and be done with it? But whatever. The calculator does have that. And that is one of those extra functions here that are in the math menu. You can also transpose, you can rotate that matrix. You can get the dimensions, you can fill it up with numbers. You can get an identity matrix, which would be ones on the downward diagonal, zeros everywhere else. You could create a random matrix, all these different things here, dump it into a list, add, cumulative summations. That RREF is probably the handiest one on the list, though. Row swap and row add. That's what we were doing with Gaussian elimination. You can do that one step at a time in a calculator. Why you'd want to do that, I don't know. But there you could multiply the whole row by 4 or whatever. Okay. And so, yeah, there's more stuff in there. But that's what we need to know about matrices and determinants. And now we can kind of get started. The book has a big thing where they describe all in gory detail how you get Cramer's rule and how it all works. I don't need you to know all that. We're kind of interested in this part right here and in this part right here. And the reason we're interested in those two parts is because we can get X and Y out of a system of equations by simply doing two determinants and dividing them. You've got a determinant on the top and a determinant on the bottom. So that's kind of neat. These determinants, like you see, they're not hard to do. They might be a little tedious if they're big matrices, but there's certainly nothing hard about it. You're multiplying and subtracting, right? Big deal. Okay. So don't worry about all that stuff on there. Let's give it a try. Here is a system of equations. The first thing that I would need to do is to turn that into a matrix. 1, 3, 8, 2, -1, 9. A little table of all the coefficients. There's 1, 3, 8, 2, -1, 9. And we now have our matrix, augmented matrix, if you want to be fancy, because it's understood it's X, Y, number, and there's a little equal sign, this many X, this many Y, all that. Okay. What we want to do is, and that's not a square matrix, so we can't take a determinant of the whole thing. But what we can do is take little pieces of it. And the first piece I want to point out here is this one. Okay. When we take the determinant of that, then that goes on the bottom. You can see it down here, D and D. Those are the same for X and Y, and it's going to be the determinant of that. So I'm just going to come in here and say I need to take the determinant of the first two columns. Now, if you had more columns, X, Y, Z, T, P, you'd want everything, if it's a 5 by 5 with that extra column vector on there, just grab all that. But we've got 1, 3, 2, -1. Okay. I need to take that determinant, and that's not hard to do. Let's go ahead and do that. When I go this way, I'd have 1 times -1 would be -1. And then I got to subtract 6 minus 2 times 3 would be 6. And so on the bottom, I'm going to get -7 like that. And the thing is that for Y here, it's that same determinant right there. So I can go ahead and put that on the bottom for this one. Okay. In both places. All right. Now this is what needs to happen next. I'm going to erase the square. And I'm going to come in here and remind you again that my X's were in the first column and the Y's were in the second column. And then I've got these numbers over here. And what we're going to do is we're going to pick up this number column and we're going to replace it into the X column when we want to solve for X. And eventually we'll put it into the Y column when we want that. So the determinant that I need to do here for this guy, for dx, I need to pick up the 8 and the 9 and replace the 1 and the 2 with it. Okay? When you want to solve for x, put it in the x column. So that's going to make an 8. And I'll go ahead and put the 9 down here. There's that column that we replaced. Here is the one like it started out, the 3, -1. And I take the determinant again. So 8 times -1 would be -8 minus 27. I believe that is -35. And -35 divided by -7 would be +5. X is equal to +5. That's pretty slick. I ain't gonna lie. Okay. That's a pretty good trick right there to do that. And in the days before calculators, you could see how that would be even more fantastic, that you could just do this little simple arithmetic thing and solve these big systems of equations. I'm going to move this down just to make some room. Okay, now what we need to do is take that same number column, if you will, that last column, and replace the Y column with it. So I'm going to take this right here, and I'm going to replace the 3 and the -1 with an 8 and a 9. All right, we're going to leave the first column alone. Where am I? Right there. Okay, and so there's that 1, 2 in the first column, but I need to replace the second column with 8, 9. All right, and now I take the determinant of the top. I'd have 1 times 9, subtract 2 times 8, still got the -7 on the bottom. If you had 6 variables, it would always be the same number on the bottom. Okay, we only have 2 here, but 9 minus 16 is going to be -7. I got the -7 in the denominator. -7 divided by -7 would be +1. They're telling me that x equals 5 and y equals 1 is the solution to that system of equations. Wonder if that's true. Could I check it? Oh, yeah. All I got to do is plug those numbers back in and see if I get the right thing. So down here on the bottom, I would have 2 times they're saying x is 5 minus 1. That would be 10 minus 1. That's 9. It worked, right? And then up here, if I put in 5 and 1, I'd have 5 plus 3 times 1. I'll be darned. That's 8. This actually works. Can you imagine? Crazy. All right. Here's a couple more. And so to get X downstairs, I've got the 3, 8, 4, 11, just the first part of that. I want to take that determinant. And then up top, I need to take the determinant. I'm going to pick up the 5 and 7, put it in the first column, and keep the second column. And so I'm going to get 55 minus 56 would be a -1. I guess we'll write that out. And then below, we're going to have 33 minus 32 is a 1. And so our answer there would be -1. When I do to go y, I know that the denominator is going to be the same, so I'll just go ahead and put the 1 down there. And now I need to pick up the 5 and the 7 and replace the 8 and 11 with it. So just kind of ignore the second column and go 3, 5, 4, 7. And up top, I would get 21 minus 20. Dividing that by 1, it's a +1. All right, and you could check that back and make sure it works and stuff. But that's all that's involved with it. You can actually kind of do it here in the problem. Um, for this one, I could just say 12 times a negative 3 is going to be a negative 36, and then I'm subtracting 2 times 3 that way would give me a 6, and that's going to put a 42 on the bottom. Negative 36 minus 6. Yep. Okay. And then I could contrive some way to do the top. I could come in here and I got to do uh, this one times this one would be 15 times negative 3 would be negative 45. You could see if you did this, sat and did this all day, you could get really good at it. 13 times 3 would be 39. And I don't know, what is that? That would be 70, 84. Okay. Negative. And the bottom was also negative. So I get a positive 2, I believe, if I did all that right. Okay. Um, you can see how you could crush your way through these pretty fast, right? When I go to do the second one, of course, I've still got the same number on the bottom. And now I'm looking at 12 times 13. That would be 144. And another 12 would be 156. Um, minus 2 times 15 would be 30. So that's 126 over 42, and I believe that's going to be a 3. This is positive. That one's negative, negative 3. Okay. So those are kind of fun, and that's not a bad way to especially in the days before calculators. This was hot stuff. Okay. Here is a 3 by 3. This is the last slide of the last video that I have for you. Just kind of wanted you to see how to do this, and maybe you'll get some practice with my open math, maybe not. I don't really know. But the matrix here would be 1, 1, negative 1, 6. And then I've got 3, negative 2, 1, negative 5, and 1, 3, negative 2, 14. Okay, so this one's a little bit bigger. There's our matrix, 3 rows, 4 columns, and of course on the bottom, I want the determinant of all of that stuff. The first three columns here. Okay, so we're going to focus on that, and of course you've got to go through, take the first element 1 times the this part. Negative 2 times negative 2 would be 4, and then subtract 3. Right, that move over to the second one. That's a 1, but I got to remember to change the signs. And now I've got 3 times negative 2 would be negative 6. And I've got 1 times 1, got to remember to subtract that one. And then finally, I'm ready to go over here to the last one. It's got a negative 1. I don't change the sign on this, so this is plus negative 1, still going to be negative 1, like that. And I've got the ones right here that I got to do. 3 times 3 would be 9. Minus 1 times negative 2 would be negative 2. I'm subtracting it, so 9 plus 2 would be 11, but I don't guess we need to do that just yet. And that's what I need to do there. Let me get all that scribbling out of the way, and we'll clear the deck for round 2. I lost a digit there, which was a 3. One of my elements got erased. Okay. But anyway, we could go ahead and get the denominators. 1 times 1, which is just 1. And then I've got negative 7 in here times a negative 1, which is going to be plus 7. And then I've got 9 plus 2 would be 11. Multiply that by a negative 1. I get negative 11. Okay. And I think I got a little ambitious with my line there. So we will shorten that up. And there we would have what? 8 minus 11 would be a negative 3. Okay. Then I got to do the top. So this is where I would come in and take that 6, negative 5, 14, the last column, and replace the first column with it. And you can do that however you want. I think I'm going to come down here and just scribble it in real quick. I'm going to take the last column, 6, negative 5, 14, and replace this column with it. So I've still got these two right here. So I can just kind of copy those. 1, negative 1, 2. Oh, I lost two numbers. So what's the other number? That's a 1. Okay. Um, yeah, 2 and a 1. Right where? I got lost again. Little dot, where are you? I'm not even seeing anything. Here we go. Here we go. Okay. So, yeah, here we go. Taking this column, putting it in the first place up there at the top. We did that. All right. That would give me a 6, 1, negative 1, and a 5, negative 5, 2, 1. Here we go. And a 14, 3, negative 2. That's what I need to take the determinant of. I'm going to grab that 6 in the front. I'm going to take so we got this one. I got the 2 times the negative 2 would be a negative 4 minus 3 times 1. Move over to the next one. Don't forget to change the sign. And then I'd have the ones on the outside. So negative 5 times negative 2 is a positive 10. Subtract 14 times 1. Move over to the last one there, which is a negative 1, and I'm adding. So adding a negative 1 is still a negative 1. And I've got the negative 5 times 3. I'm over here now, this one and this one, and then subtracting 28 right there. All right. Oh boy, let's see. I got a negative 7 times 6 would be a negative 42. And right here is a negative 4 times a negative 1 would be a positive 4. And a 15 and a 28 is 38, 43. This is negative, that's negative. Negative times a negative is a positive 43. So I'd have negative 4 plus 4, I believe, is a 0 there if I did that right. And one of the solutions could and probably is 0 uh, right there. Okay. You would do exactly the same thing for y. We already know that the denominator is negative 3. No need to do that all over again. I would start over and make, I'm not going to do this here just to, but for y, we would take this column, the last one, and put it in the y column. And we'd have to take the determinant of 1, 6, negative 1, 3, negative 5, 1, 1, 14, negative 2. Whatever the determinant of that is, I'm going to just call it dy here to save a little bit of time and space. And we get that the same way we have done a couple times now. That would give me the x value, so I'd know x. This one we just did would give me y. I still got to do z, right? So I just take that column and put it in here, write out that square matrix, get the determinant, and I could take z equals the determinant of that z matrix, divide by negative 3, and you'd have your three answers there, 0 and 4 and 6 or whatever it is, right? Okay. So that is Cramer's rule for a 3 by 3, 3 variables, 3 equations, and it's very doable. And you just kind of got used to doing these things by hand back when I was, in your seat. Um, but now you'd probably step in here with a calculator and just do the RREF. But some of these things are good to know how to do. We lean on calculators too much as a crutch, and sometimes I'll ask people in class, "What's 2 plus 5?" And they'll grab their calculator, like The more facility you have with these, the more practice kind of working with numbers and stuff, the better you get. And I'm getting kind of rusty too because I lean on mine. But I like to know how things work and where they come from and why people started doing these things. And hopefully you do too. Thanks for everything. Hope you've had a great semester. Hope you go on and do great things and make $1 million. And if you want to, I don't, but all success and happiness to you. Thanks. Have a great day.